Okay, so we were talking about this cloud development kit the last day, which is a framework that allows us to provision infrastructure uh, in a to automate the provisioning of infrastructure using code. It's specifically for the AWS platform, though it's a slight disadvantage of it, I suppose, over something like Terraform. And I talked through the kind of the idea behind the kit and how we structured the code using this particular framework. And I was about to just do a demo. Now, of course, if you have, oh yeah, just before, now some of you may have worked through this lab, um, which is great. If you haven't, then you certainly would need to do it this week. I'm not sure if I said this the last there or not. The idea behind this one here, I think I did actually mention it, but I'll just repeat it anyway. When you're using the AWS Management Console, it's kind of recommended that you should not be logging in using your AWS root user privileges, just from a security perspective, really. The better approach would be to create an IAM user, give that user the necessary admin privileges, and then always use that IAM user when you're accessing the web-based management console. And this lab here steps you through creating an IAM user and giving that user the necessary privileges. So if you haven't done that already, I would recommend you following the steps in this. And then for this lab and all subsequent labs, when you're using the management console, log in using your IAM user credentials rather than your root user credentials. Okay, so if I go back to our slides and if we pick up the story, maybe here. So when we're using this CDK Cloud Development Kit stroke framework, these are the main programming kind of concepts that you're working with. They actually translate into classes, really. So we have at the top level, we have the notion of a CDK application or a CDK app. And a CDK app is made up of one or more stacks. Stack is a term that you would have come across in the cloud architecture module last semester, those of you that did it. You would have come across it in the context of the CloudFormation service. A stack is made up of constructs, which is a CDK kind of idea. And a construct then is made up of resources. Now, we don't, construct is the lowest level programming construct that we use in the CDK framework. A CDK construct will result in the creation of one or more resources up in the AWS cloud. Yeah, we don't have this, so this is not a programming concept as such. And here's a kind of a visual representation of the kind of relationship between these different concepts. In relation to constructs, then I was talking about this idea that there are three levels of these constructs: L1, L2, and L3. Yeah, an L1 construct results in the creation of one resource, and there are a number of L1 constructs. An L2 construct will result in the creation of many resources in the cloud. And L3 is just higher, a larger number of resources again. Uh, L2 is the one that we mainly deal with, I said, and L1 we come across every now and again, but it's predominantly L2. I also, this is the structure of a CDK project. This is the one that's created by the CDK framework when you kind of run CDK in it. Now you can add other folders to it if you want to, and we will later on. But the file in the bin folder, you tend to leave that structure alone. You may need to make some edits to this TypeScript file. But you tend to leave the folder name the same. You can change it, but if you do, then you have to go making some changes to your to this config file, this JSON file here, which we don't tend to do. In the lib folder then is where we put our CDK stack code. Remember we said an application is made up of one or more stacks. So you would have a file here per stack in your application. The file names are not significant, right? You can change them to whatever you want them to. So it's in the lib folder. That's where we'll spend most of our time. We will also spend a lot of time in a Lambda folder, which doesn't exist here because lots of CDK projects don't use the Lambda service. Okay, but before I talk about Lambda, I've created a simple CDK project for myself, and here it is here. Now again, as I said there at the outset, if you walked your way through the lab, the second lab, the CDK lab, let's call it, as opposed to the IAM user lab, then you're kind of ahead of me in terms, but that's okay. So here's my CDK project that I've created for myself, and we're mainly interested in this file here, the stack file. Okay, and if I go into it, you can see that I am creating a class. I can call the class anything I want to, but note here that it extends the CDK stack class, which is a class that comes with the CDK framework. And I'm importing the CDK library itself here. Okay, so that line, by virtue of the fact that I'm extending the stack class, that makes this class a stack in my application. And if I just jump over to here I am creating an empty CDK app, and here I'm essentially adding my stack to the app, although we kind of do it the other way around in that we link the app to the stack. Yeah, so that's how we connect them together. Ignore this stuff here for a second. So here I'm adding my stack to the app. And so what is in my stack? Or what do I want to have provisioned? What infrastructure do I want to have provisioned in my AWS account when I run this stack, execute this stack? And so what you will notice is that the majority of the code goes into the constructor, to the constructor for in your stack class. You can add other methods as well, but I don't think we have any example where we add other methods. But you can. We may have one or two examples later on. So all of the code tends to go into the constructor for my stack class. That's where you put your infrastructure code. And what am I doing? Some of this stuff you could nearly work out without having any experience of this using the CDK framework. Here I'm just grabbing a reference to the virtual private cloud that was created in my account for me. Every time you create an AWS account, as you know, you get a VPC, Virtual Private Cloud, created automatically and for free, kind of, and associated with your AWS account. You can create a new VPC if you want to, and we could do that, but we're not, because if we did, that would incur a cost. But aside from that, we don't really need it. I'm going to skip over. I'm going to skip over this for a second. Anywhere we create a new object, that is effectively creating a new construct. Okay, construct in the CDK sense now, right? So I am creating a new, and in this case, it looks like I'm creating a security group construct instance. Now I can tell you that security group is an example of an L1 construct, which we'll just live with for now, okay? And if I scroll on a little bit further on my code, I'm going to ignore this for now. Here I'm creating another new thing for myself. In this case, I am creating a new EC2 instance. So instance here is an example of another construct that comes with the CDK framework. And this is an example of an L2 construct. So when this code here, when this EC2 instance construct is created in when I run my code, and it's, you know, the CloudFormation template is generated and the template is uploaded to the CloudFormation service. This will actually result in the creation of, obviously, it will result in the creation of an EC2 instance in my account, but it will also create an IAM role and attach it to my EC2 instance. And it will create an instance profile and attach that to my instance. So that's a simple example of what I mean by an L2 construct. So instance is an example, EC2 instance is an example of an L2 construct because it actually results in the creation of many resources up in the cloud. Again, the resources were an actual EC2 instance, an IAM role, which is linked to my EC2 instance, an instance profile resource, which is linked to my EC2 instance. I'm not going to go into, well, you've done a lot of this stuff anyway in the cloud architecture. We're not going to go into talking about what do we mean by an instance profile, what do we mean by an IAM role. I'm kind of assuming people are familiar with those. So this is a good example of an L2 construct, whereas security group, that particular class, if you like, is an example of an L1 construct because it only creates one resource up in the cloud for me, one security group resource. Yeah. The other thing is, what you will notice is that for every construct class, so, you know, this is obviously a class because I'm using the new operator in front of it. So sorry, I've highlighted the wrong one. I should be highlighting this one here. Sorry. Oh yeah, so security group is a class that just comes with the CDK framework, just like instance further down the code is a class that comes with the CDK framework. And what you will notice is that every construct class, whether it be L1 or L2, we won't see any L3, but every construct class has the exact same signature. It has 3 parts to the signature. And you can see here there's 1 argument, 2 arguments, and the 3rd argument is this object. Yeah. If I go down to the other one, it has 1 argument, 2nd argument, and the 3rd argument is an object. Okay. The meaning for each of these, so every construct class will have the exact same signature. And the meaning for each of them is the first one, you're essentially attaching the construct to something. You have to attach the construct to something. And typically you're attaching the construct to a stack, right? Because as we said, a stack is made up of many constructs. So the this here just refers to uh, the enclosing object, which in our case is a stack, of course. The second argument is just a string, kind of an identifier for this construct. And in this case, it's just an identifier for our security group instance. The third argument is the configuration of that uh, construct. In this case, the configuration that we want for our security group. Same down here. We want to create an EC2 instance. What do we want to attach that instance to? We want to attach it to the kind of the current stack. Here's just an identifier, string identifier, which is only used by us really. You know, it's not used by the EC2 service now in any way. It's just an identifier. And the third argument then, which is this large kind of object, that is the configuration that we want for our EC2 instance. Now, the structure of the third argument, that will be different for every type of construct that you're creating. And we can see in the two that we have in this case, the configuration setting for, I mean, it makes sense that the configuration for an EC2 instance is going to be very different from the configuration for a security group, right? How do you find out what is the structure of the object for a particular construct? Well, one way of doing it is if you mouse over, if I mouse over this, I can actually get at the TypeScript declaration file for this class. Okay, so here we have a declaration of the instance class, which comes with, which is contained in a TypeScript declaration file. And what I want to find now is I want to find the constructor for this class. So it's got quite a lot of kind of properties, lots of read-only properties. We don't have to really look at those. Let's see. Here's the constructor. Okay. The first argument is, that's the one we set this to. That's actually, the scope is a better name, like what is the scope of this construct, and the scope is nearly always the enclosing stack. I've never had anything other than the enclosing stack. The second argument is an identifier, as I said to you. And the third argument we refer to as the props argument. And the props, I said, is going to be different for every type of L1 or L2 construct. So for this particular one, if we want to find out what is the shape of this object, well, same as before. If we mouse over it and click, we're inside in the same TypeScript declaration file, but here it is here, and lo and behold, it's just an interface data type. So, you could read down. I'm not telling you now or requiring you to necessarily drill down into these and find out about all of the parameters. That's not necessary at all. But I'm just showing you that you can find out what are the various options available to you when it comes to configuring a particular type of construct, whatever the construct is. In my case, security group and EC2 instance. And these types TypeScript declaration files, obviously, they come packaged with the CDK framework, which I have installed uh, with this project. I have installed it via the package.json file. If we go into the package.json file, uh, let's see. There we see it there. That's essentially the framework, right? It's the entire library that comes with as part of the framework. So the TypeScript declaration file, or well, there was only one that I was looking at. It's inside there somewhere, and you can obviously find it over in Node modules, but and all that kind of stuff if you needed to. So that's just by way of just some background. Any questions about what I'm doing so far? Like, I think it's always useful to be familiar with kind of what's happening one level or maybe two levels below your programming level. The programming level is, uh, is what you do here, sorry, what you do inside here. But to be able to drill down a little bit further may be useful, when you're debugging. I'm not sure if you necessarily need to go drilling down, but if you're curious, by all means, just poke around, really. So I ran, um, and that, oh, sorry, so that's my stack. My stack is consists of just two things: a security group and an EC2 instance. And I've obviously kind of connected the security group is linked to the EC2 instance because you can see, uh, here I'm linking the security group that I've defined to the to my EC2 instance. And there's some other settings as well. Okay. Uh, the rest then is just, this is my essentially my startup script that I want my EC2 instance to run. You might remember from the cloud architecture module, an EC2 instance has this notion of what's called user data in the language of EC2, but essentially user data is kind of a startup script that you want your EC2 instance to run when it has been fully provisioned. And if you kind of skim down through the code here, this is just terminal code really. All I'm doing is I am kicking off a web browser, and that's all that's going on there, right? Here I'm just well, here's where I'm creating my security group, and I'm also creating an inbound rule from my security group. Now, again, I'm assuming people are kind of familiar with that from the cloud architecture module. So from the command line, I just ran CDK deploy. If you look at the bottom of the screen, I ran CDK deploy. Now I did it earlier just to speed things up a little bit. And here's the result of the CDK deploy, and it all seemed to work fine. Sorry, there's just one other thing in the code here. Sometimes you may want to output something to the terminal when you run CDK deploy, and this is how you do it here. So I'm just outputting the name of the public domain name as opposed to the public IP address. I'm outputting the public domain name for the EC2 instance that has been provisioned by AWS for me. I'm outputting that to the terminal, and you can see it. Let's see, where is it? Here it is here, right? Okay, we'll come back to that in a second. If I switch over now to my AWS account, oh, sorry, yeah, back again. Something else I forgot. If I go back to here, um, only we won't need to do this for, I think, for the rest of the stacks, actually, the rest of the CDK apps that we will create in this module. But for this particular one, uh, you do have to kind of tell the framework uh, what is what what region are you deploying this stack to, and what account are you deploying it to. And we're passing that as kind of environment variables uh, when we add the stack, when we kind of link up the stack with the app. But I think this is the only time we'll need to do that. The other thing is, so I've ran CDK deploy here, okay? Now, if you remember from the last day, what the CDK deploy command does is it takes my TypeScript code, both this file and this one, and in particular this one, takes all of this and it generates the CloudFormation template for this stack. And you can actually find that template. Well, to finish the story, it then uploads this CloudFormation template to the CloudFormation service, and the CloudFormation service interprets it and talks to the various services that it needs to talk to. In this case, the only service it needs to talk to is the EC2 service, because all of the resources that I want to create are managed by the EC2 service. And the EC2 service provisions the resources. But the actual template itself, if you do want to look at it, there is a folder over here on the left called CDK out. And if we open up that, and if I pull this over a little bit, sorry now. You can see this file here, right? This is the CloudFormation template, albeit in JSON form. There's probably a way of getting it to generate it in YAML form. Either way, we won't really need to go looking at it. But if I do just quickly look at it, and in here is where you'll find the actual resources that we want to have created for us. So if I do a search for type, so you can see this one here is clearly the CloudFormation code, template code for creating my security group. But if I just do a bit of a search on, let's see. You can see here, right? It's creating an IAM role. There was nothing in my CDK stack about creating an IAM role, but the IAM role is actually created as a result of the EC2 instance construct in my CDK stack. If I do another search, this is the EC2 instance profile resource. Again, there's nothing explicit in my code, but it's as a result of the EC2 instance construct in my stack. This is the actual CloudFormation code for CloudFormation template code for provisioning an EC2 instance. Okay, so that's 4 resources by my count. 3 of them are linked to the EC2 construct, EC2 instance construct. 1 of them is linked to the security group construct. Again, that's again by way of background. let's go over to EC2, or sorry, to the uh, management console. And if we go into the EC2 service, and if we go into instances, this is it. This is from all the work that I'm doing, so it's not linked to my CDK project. Here's the EC2 instance that was created for me uh, as a result of deploying my CDK stack. Uh, and if I go down in, well, yeah, if we jump over to the CloudFormation service, which is probably would have been a better place to start. And if I look at stacks, here's the stack related to the stack file that I was looking at. So there, you won't be able to see the CDK app as such, because you might remember I said that uh, uh, you deploy, okay, we're deploying the app, but really what we're deploying is all of the stacks in the app. And there's only one. So, and you can drill down into it if you want to. Okay, so that's confirmation, and we can see that the stack was created successfully, so there weren't any issues. And back to our EC2 service. And if I select the actual instance and we can find the security group. So here's the security group. And there was just one inbound rule, you remember, and there were no outbound rules. Well, sorry, that's kind of a default one. The inbound rules. Sorry, no. Okay, so there's only one inbound rule. It accepts HTTP traffic. Of course, just to make sure that my EC2 instance is running successfully, because I've deployed a web browser into it, and I'm getting as output here from my CDK stack when I deployed it, I'm getting the domain name from my EC2 instance because it has a public IP address. I could grab the public IP address, but I'll grab the domain name instead. Copy that. Open up a browser tab. The site can't be reached. Why is that now? Let's go back to just try using the IP address instead. Okay, so that's the actual kind of web page that I configured for uh, web my web server. I'm not sure why the domain name doesn't work there, but okay, we'll just conveniently ignore it and push on. I'll look at it later on. Okay, so that's fine. Now, let's supposing I want to make a change to my CDK stack. And the change that I want to make is I want to add a new inbound rule to the security group, just by way of example. So that's this code here, which I'll now enable. Okay, so I just want to open up the SSH port, yeah, and I'm just adding that uh, ingress rule to my security group. And all I need to do now is run CDK deploy again, and the CDK will generate a new template, completely new CDK CloudFormation template to represent the new state of the stack that I want. It'll upload that to this CloudFormation service. And as I said the last day, the CloudFormation service then, it will do the hard work. It will work out what is the difference between this new state of your stack and the current state of the stack that exists up in the cloud. It'll compute the difference and then talk to the necessary services to effect the difference. So if I just do CDK deploy again now, okay, so I am opening up another port, so that is a potential security risk. So it asks me, am I okay with that? And now behind the scenes, as I said, it's the CDK framework is generating an updated, a completely new CloudFormation template. It's uploading it to the CloudFormation service, and the CloudFormation service is kind of uh, is reporting back to us as it's working its way through the updating of our infrastructure, and it has completed it, which means if I now go back to the management console and I'm just going to do a refresh here. I'm going to go back into my security section, bring up my security group. It has probably created a new security group and deleted the old one. Either way, if I do a refresh of this, because that's the old one, I'd say. And we can see now that the second rule has been added. Yeah. So that's great. And equally, it's not updating a stack isn't always adding new stuff. It may mean removing stuff as well. So just finally to demonstrate that, and we'll stick with the same one just for simplicity's sake. Suppose I want to remove that inbound rule. So I've commented out my code again and I'll do another CDK deploy. And so that's really the benefit of this kind of form of infrastructure as code, as opposed to in the bad old days when we were doing it all by Python scripts using the Boto tree library, which was the uh, let's go back to here and maybe we'll just gamble it and just do a raw refresh at this level. So we should see one of the rules gone at this stage. And there we are. So we're only left with the HTTP inbound rule. Okay, simple illustration of our infrastructure as code and modifying our code and just letting the framework and CloudFormation take care of the kind of ugly stuff of updating the state of our infrastructure. I'll just pause in case there are any questions, anything I haven't explained clearly to you. I still don't know why that domain name doesn't work though. Let me just, unless, no, I don't think it's that. Yeah. It's working now. Let's do a refresh. Yeah, it's working this time. So I don't know, maybe the server wasn't fully up and running, but that's hardly plausible. But either way, anyway, it's working at this stage. Right, let's push on. So we've that's a simple demonstration of the CDK framework, and we will be using it now for the rest of the first half um, of this module. But we kind of have a sense of what it does first and how it makes the automation of provisioning of infrastructure very easy. So let's park that and let's move on to, although as I said, we're going to be using it again now when we move into this section, and we want to talk about serverless web APIs. And the idea here is that we want to be able to create a web API up in the Amazon and deploy it to the Amazon Web Services, but we want to use a serverless architecture for our web API, as opposed to, deploying it inside an EC2 instance. So that's kind of the big picture. And we want to provision the infrastructure using our CDK framework. Okay, so let's walk through some of these slides. Okay, so serverless web APIs, and in particular, what are the AWS related services that facilitate the creation and deployment of a serverless web API? Just to be sure, what we mean by serverless is it's not, it doesn't mean that there aren't any servers involved in the cloud. There certainly are, but the serverless um, idea is that you, as the developer, you don't need to worry about provisioning servers, like provisioning an EC2 instance and configuring those servers and maintaining them and making sure that they're up and running and scaling them if need be. All of those concerns now are actually taken out of our hands, and the AWS Cloud, if you like, manages those aspects of our infrastructure for us. So, as would have been said to you last year, we lose a certain amount of control as a result of uh, um, trying to achieve a serverless architecture. But the upside is that uh, we don't have as many low-level responsibilities. Of course, we know what a web API is. Okay, a web API is essentially functionality, and this is kind of the most general form of what we mean by a web API. It's some functionality that's running in a server or running in the cloud, let's say, running on a server, I guess, and it has some sort of an interface, typically over HTTP. And so that because it's accessible or invocable over HTTP, then any kind of client can potentially trigger the execution of this functionality by requesting the execution over HTTP. So uh, AWS has many serverless services in the different kind of aspects of that an application may need. Clearly, it has serverless compute services. The dominant one would be the AWS Lambda service, but there are others. There's the Elastic Container service as well. There is a serverless version of that, but the main one is the Lambda service. So, if I go back to the previous screen, we're going to be using the Lambda service to essentially kind of host some functionality that we want to have executable up in the cloud. On the database side, because any kind of web API or any doesn't have to be a web API, but lots of cloud-based applications need some form of persistence, data persistence, i.e., we need a database. There are lots of serverless uh, database services provided by AWS. One of them is DynamoDB. I'm saying here it's a NoSQL type of database service, although I have a question mark here because it's a little bit initially it kind of looks like it's a NoSQL type of database and you can use it in that way, but it is slightly different from your kind of standard NoSQL stuff that you might have come across before, like for example MongoDB. I'll allude to it a little bit when I talk about DynamoDB, but treating it just as your standard NoSQL uh, is where most people start off. But if you drill down a little bit deeper into some of the ideas behind DynamoDB, you start to see that it's quite different from your typical NoSQL type database. Um, Moving on, there's a service called AWS Cognito, which is a serverless service for essentially managing user accounts, as in user registration, user login, all of that kind of stuff. Uh, so rather than us having to manage our users, maybe in some sort of database, we can use this Cognito services instead to do that for us. Now, it's probably using some sort of database behind the scenes, but we don't interact with it or provision it in using kind of database concepts, as we might see. There's a service called API Gateway, which is a way of kind of having a front end to your Lambdas, as it turns out, but it's kind of it's a kind of a client-facing interface to the functionality itself. So again, if I go back to the previous screen, API Gateway would tend to sit here. You would create an API Gateway resource as the kind of interface to your Lambdas in our case back here. We'll see all of that in a while. S3, which you're definitely familiar with, but that's really a serverless service as well, even though it may not have been categorized as serverless when you were talking about it last year. So it's essentially kind of a file storage, but It's also serverless in the sense that we don't have to worry about provisioning the servers that are managing the file systems for us. And there's other ones as well, SQS SNS for messaging. Again, you would have looked at those last year. We won't look at them in this module. And on it goes. So there's lots of, this is actually, Aurora is actually a relational database, a serverless relational database service, um, which we won't be using either. And there are other examples. So overall, there are many serverless services provided by AWS for us for any type of kind of server-side application that you may want to deploy to the cloud, whether it be a web API or not. One of the main ones we want to look at is the Lambda service. And again, I am aware of the fact that ye have looked at Lambda in the cloud architecture module, but some of ye did not do that module, so I do need to cover some of the basics of it before we get into the actual coding side of it. So what is Lambda? As if we don't know by now, I suppose, I've kind of alluded to it a couple of times. It's a serverless compute service. It's event-driven, meaning so the idea is that we're going to have this functionality deployed to Lambda. How do we actually trigger the execution of our functionality? Well, it will be triggered by means of some event that occurs. So the occurrence of the event will cause the execution of our functionality. Okay, so it's event-driven serverless service platform. It runs code, and what you will see is that the code is actually just a function. So it's quite a granular. The functionality is quite granular. We don't have to write an entire kind of mini application and deploy that to Lambda. We can deploy something as small as a function, and then we somehow link some events to the triggering of that function. It manages so we talk about the Lambda service and we talk about the Lambda function. The Lambda function is what we write. That's what we're talking about here. The Lambda service, it manages our functions for us, and it manages the triggering of the execution of our functions for us. Okay, so you'll often hear me talking about the Lambda service and the Lambda function. So make sure you understand the distinction between the two of them. So the Lambda service also manages the computing resources that your function may need in order to execute. Clearly, the function is going to need some virtual CPU power. It's going to need some RAM. It's going to need some network capacity. So the Lambda service will provision those resources for us, for our function, in order for our function to execute. Code that runs. It's kind of what happens behind the scenes is that what the Lambda service does is it creates, I'm saying here, it creates a container. I think in the language of Lambda, it refers to it as a micro VM. Okay, micro VM stroke container, they're kind of the same thing, really, in general terms. So what the Lambda service does is it quickly creates a micro VM instance for us, and it then loads our Lambda function into that micro VM, and then it executes the function. So the micro VM is the runtime environment for our function. Yeah. Ephemeral in the sense that once the function has completed execution, then it just throws away that micro VM. And if another event occurs that's linked to our function, it'll create a new, fresh micro VM instance, load our function into it, and now our function can execute. Although there's a slight variation in that sequence there, though. having created a micro VM instance and executed our Lambda function inside it, if another event occurs quite shortly after the completion of the first execution of our function, it will actually hold on to the micro VM for a short period of time, just in case it needs to kind of use it again. Yeah. So it doesn't always create a fresh micro VM instance for every single execution of our Lambda function. And that's a point I'll come back to later on. But aside from that, these micro VMs are things that can be spun up and thrown away very quickly, which is why we refer to them as being ephemeral. This is just another kind of acronym that we often mention when we're talking about the Lambda service, FaaS, function as a service. So this is just a visual representation of the kind of runtime. We've got some sort of source of our event. We've got the Lambda service, and we've got our Lambda function, okay? So there are the three kind of actors, if you like, in the execution of our Lambda function. So this is the thing that we write. We code this. So down here, I'm saying the event source, this thing over here, it could be anything. It could be, I'm saying it could be a HTTP request. It could be some state change in a database. It could be a state change in some other resource, like an EC2 instance. An EC2 instance goes through some sort of state change, and that actually triggers we want our Lambda function to execute as a result of that. We certainly won't see that, but the idea of a HTTP request hitting our Lambda service will cause the Lambda service to trigger the execution of our Lambda function. And of course, as I was saying there on the previous slide, kind of what happens behind the scenes is that it creates my box here now is my micro VM. The Lambda service creates this micro VM instance, spins one up, loads our function into it, and then gets the function to execute. So the event source, we often refer to it as the trigger as well, the trigger for our function. It essentially, there are many, many different possibilities. Of course, you control what are the event sources for your Lambda. That's something that you configure in your CDK stack file. The Lambda function can be written in any language you want to. The Lambda function, the Lambda service doesn't care what the Lambda function is written in. It obviously impacts on the micro VM, because let's supposing it's written in Python, then clearly we have to have a Python interpreter contained within this micro VM. If it's JavaScript, we need to have a JavaScript interpreter, and so on. Let's Lambda service. So the service manages, yeah. Oh, sorry, yeah. As we'll see maybe later on, it actually takes care of auto scaling. So if there's a high volume of events targeting our particular Lambda function, then what we'll see is that the Lambda service will create parallel, if I go back to the previous slide, it'll actually create parallel instances of micro VMs and load each of them with a separate copy of your Lambda function. It doesn't sort of run this multiple times. It actually will create parallel executions of our Lambda because of the high volume of occurrences, concurrent occurrences of the event source. Hence, it takes care of, the Lambda service takes care of scalability in that sense. Load balancing between the various multiple micro VMs that it might have spun up for us takes care of making sure that the operating system, because there is an operating system obviously running inside the micro VM, and it takes care of making sure that the operating system software itself is properly maintained, course, it loads the operating system into the micro VM as well, because initially the micro VM is kind of empty, if you like. It has to be loaded with an operating system and then loaded with our function. It makes sure that that uh, like these micro VMs that I'm talking about, clearly they're actually running on some server, some hardware somewhere. Um, and so if you're going to have multiple micro VMs, not necessarily all running the same Lambda function, but they're all going to be running on the same physical hardware. And so you obviously want to make sure that the functions within a micro VM are isolated from all other micro VM functions. And AWS will kind of guarantee that. Otherwise, a function could potentially uh, get access to another micro VM. That's something we don't want, obviously. And so the Lambda service does all of these things for us, right? If we weren't using the Lambda service, if we were just using EC2, we'd have to take care of scalability and load balancing and making sure that the right operating system was being loaded into our EC2 instance. Yeah. It takes care of utilization as well. In other words, providing sufficient RAM memory, providing sufficient uh, virtual CPUs, networking, etc. And all of this stuff is okay. I'm going to skip over that. Can I just go back? Sorry for 1 second. No, okay, let's keep going. This is what I'm calling the anatomy of a Lambda function. The main part of your Lambda function is the actual function itself, which in the case, this is TypeScript. In the case of TypeScript, this is going to be our Lambda function code. Okay, you can call the function anything you want to, but conventionally we call it hard handler. So this is the thing that is triggered when whatever event occurs, right? Uh, so the handler is the function to be executed upon invocation. That's all right. The handler function, it is a function in every sense. It takes two arguments. We don't tend to use the second one, but it's there anyway. The second argument would allow us to access the micro VM itself if we wanted to kind of access a certain part of the operating system. But we don't ever need to do that really. Or if you wanted to access the temporary kind of file system that's available within the micro VM. The first argument is the one that we're really interested in. And as you can tell from its name, this argument contains the actual payload associated with the event that caused the execution of our function. So we're going to take, later on, we'll look at, well, what is the shape? It's an object, okay? The TypeScript object. What is the shape of that object? You can have other functions as well inside in this. This is going to be in a physical file, obviously. You can have other functions if you want to. And those other functions presumably are being invoked within your handler. But the function that you export, and again, as I said, you don't have to call it handler. The function that you export is the function that is triggered or executed to handle the event, let's say, to process the event. Now, there is code up here as well, though, which we refer to as initialization code. And this initialization code, typically it does things like make a connection with another service or another resource. A simple example of that would be if this if this handler here wants to talk to a database. Now, we where you create the connection to the database is in your initialization code. You can put it inside in the handler, but that's just considered bad practice. The place to put that would be in your initialization code. Similarly, if your handler was talking to, let's say, the SQS service to publish a message, then up here in the initialization code is where you would create the connection to the SQS service. Yeah. Which is what I'm saying down here. Code executes. Oh yeah. So I was talking there about, so an event occurs, the event is linked to, let's say, this particular Lambda function, and that link is created by virtue of code that you put into your stack file, as we'll see later on. An instance of the event occurs, the Lambda service creates or spins up a micro VM. It loads my code into the micro VM. And the first thing it does is it executes the initialization code, and then it executes the handler. Now, let's supposing a second instance of the particular event type occurs immediately after the first one. Or at least it occurs quickly enough before the Lambda service decides to just throw away the micro VM instance, right, or delete the micro VM instance. So the micro VM is still there and it still has all of this code or function loaded in it. So the second event, what happens with the second event is the initialization code is not executed, only the handler is executed. Because what I told you about what tends to go into the initialization code, let's say it's creating a connection to a database. We don't need to create the connection to the database again. We already have it from the first execution, from the processing of the first instance of our event. So for the second event, only the handler is executed. If there's a third event that occurs again shortly after the second one, and by shortly I simply mean the Lambda service hasn't decided to throw away the micro VM that's hosting this code here, then for the third event, same idea. It skips over the initialization code and just runs the handler code. The difference, so there's two execution flows that can happen. One is it first of all runs the execution code, the initialization code, and then the handler. The second sequence is it only runs the handler. When it runs the initialization and the handler, we refer to that as a cold start, a cold startup of our micro VM. When it only executes the handler, we refer to that as a warm startup of our micro VM. Warm as in it has already kind of, made the connections to the outside world, if you like, the world outside of the micro VM. So we talk about cold starts and warm starts of a micro VM. Clearly, a cold start takes longer because it has to execute this code, and this can be if it's creating a connection to a database, then that's an asynchronous and it has to wait for the database service to respond back and saying, here's your connection string, or here's your connection to the database. So that's actually quite slow. So clearly cold starts take longer than warm starts. And we'd like to try and minimize the amount of cold starts that are required if we can. Any questions so far? No. Lambda functions configuration. In terms of configuring a Lambda function, clearly we write this code, that's okay. But what we will see as well is that we need to put something into our CDK stack to tell it about this Lambda function. And the code that we put into the CDK stack, part of what we need to configure in there is what kind of CPU power um, or capacity, or sorry, what kind of runtime capacity does this function need in terms of CPU power, RAM, networking capacity? Yeah. Now, it turns out that we can't configure each of those three. We can only configure one thing. So this is a decision that the Lambda service designers decided on. They decided that the only thing we, the developer, can configure for our Lambda function is the amount of RAM space that it will need. And based on the amount of RAM space that you ask to have provisioned for your Lambda function, that determines how much virtual CPU uh, power it needs and what kind of networking capacity it needs. It's kind of proportional to the amount of RAM. So RAM, in a way, is a way of indicating how much runtime power it needs in order to execute. And that's something that you maybe fine tune based on what kind of processing is being done by the Lambda function, by the actual handler function itself. I'm not going to go into that side of it, but I'm giving you kind of simple example here. So in terms of the RAM, the smallest amount of RAM that you can have associated with a Lambda function is 128 megs, up to a maximum of 3000 in jumps of 64 megs. Okay. Uh, and I am telling you about kind of the relationship here between the amount of RAM and the amount of virtual CPU core credits that are linked to the size of your RAM. You can look at that kind of calculation yourself. We won't really be getting into that kind of low level configuration, to be quite honest. I want to bring your attention down to this part here. So, so the Lambda service creates our micro VM and it loads our function into it, and then it triggers the kind of execution of our Lambda function. Now, there is an upper limit as to how long a Lambda function can be running for, because these Lambda functions are meant to be quite kind of short bursts of processing, whatever the nature of the processing is. It's not something that can be running for a number of hours. So if there's any kind of heavy batch processing that you might need, then the Lambda service is not what you should be using for that type of processing. You should either be using some sort of containerization or back to EC2 to run any kind of heavy workloads. So in terms of so as well as the kind of the RAM, you can also configure the timeout period for your function. The timeout indicates how long you expect this function to be executing for. And if it exceeds that, then you're essentially allowing the Lambda service to kill the execution of your function because maybe something has gone wrong in your code. The minimum timeout is, what is it? Three seconds. Okay, 3 seconds is the minimum timeout. So that's kind of the default. If you don't tell the Lambda service what the timeout setting for your function is, it'll assume it's 3 seconds. And so if your Lambda function is still executing after 3 seconds, then the Lambda service will immediately kill the execution and throw away the micro VM. The maximum is 15 minutes. Yeah. So you can control that as well as the amount of compute resources that you configure. You can also configure the timeout that you want to have associated with your Lambda function. Okay, it's all talk. Let's have a simple demo. And I just need to check my watch. Okay. Here's another CDK project, and Here's the uh, bin, the kind of the, let's call it the kind of app, the application file. Nothing interesting there. Again, creating an empty CDK app, and I'm adding one stack to the app. All right, so that's not interesting. Let's look at the stack file. And again, it's all happening inside in the constructor. And here we go. This is how we create uh, a, a lambda, or cause the creation of a lambda function instance. So here again, like we're creating a new thing. So that must mean that Node.js function is an L2 construct. And as before, we need to specify the scope. We're linking it to the current stack. We're just giving it an identifier. And here are some of the configuration settings for our Lambda function. The architecture isn't actually, I'm just setting it to, what am I setting to? ARM64, but I'd say it probably defaults to that anyway. That's not that interesting. The runtime, we want to use Node version 20, is it? So that will control, the runtime environment for our Lambda function. So clearly we're going to be running JavaScript inside in this Lambda, inside in the micro VM. Moving on, here we're just pointing at a file within our code over here on the left. And you can see on the left here, I've got a folder called lambdas. It doesn't have to be called lambdas. You can call it anything you want to. Some people call it functions. And I've got a single TypeScript file in there. This is the actual code for my Lambda function, which I'll look at in a second. Or the effect of this here is to, provision the necessary resources in order to be able to run my Lambda function. This is the actual Lambda function itself here. Sorry, here. But we'll look at that in a moment. And I am configuring the timeout. I'm setting it to 10 seconds. It certainly doesn't need 10 seconds. I probably should have left it at the default, but just to illustrate. And memory size, again, we said on the slides that the default was 128 megs. Okay, I'm setting it explicitly here, but I didn't really have to. So that's going to have the effect now of being able to provision a Lambda function in the cloud, but just the provisioning of it. The actual execution of the Lambda, then, that depends on what event we want to have associated with it. Now, in this case, we're going to trigger the Lambda function by using the AWS CLI, and you can do that for any Lambda. Okay, so that's just as a convenience, right? And that's all that's in my stack. There's only one thing, right? That's it. I don't need anything else. Some other code down here, which I'll talk about in a while. So, the Lambda function. Let's look at the Lambda function. That's even less interesting. Here's the actual function, and I don't have any initialization code. I don't need anything. Here's the actual handler function itself. And all it's doing is it's doing a console log of this message, and it's returning this object to whoever invoked it, which in my case will be, I'll invoke it from the command line. So I should get this, essentially I should get this message back. Sorry, this message back in a JSON file. The rest of it is just kind of standard stuff, right? It's a 200 response. status code response, HTTP 200 status code response. It's just some HTTP headers, I'm just including those just for illustration purposes. Uh, my function is obviously going to be invoked over the network, so it does have to be an asynchronous function. And I am wrapping it in a try-catch block. I didn't really actually have to wrap it in a try-catch block because there isn't any code in here that could throw an exception, but it's just best practice to wrap the body of your Lambda function in a try-catch block. And my catch block is, again, nothing interesting, just some standard stuff. So that essentially there's only two lines of code in my Lambda function, the console log and my return statement. Sorry, the console log and my return statement. So if I go CDK deploy, again, it's taking the stack file, generating the CloudFormation template, and it's asking me to, okay with that, say yes. It's going to generate the CloudFormation template, upload it to the CloudFormation service. Now it's also going to grab my Lambda function and it's going to send that up as well. And the Lambda function actually will be stored. It stores it actually inside of an S3 bucket. We don't really have to follow it. It's going to compile because it's TypeScript. It's going to compile this down to JavaScript and upload the JavaScript to the CloudFormation service, and that will be stored inside of an S3 bucket, kind of behind the scenes. So that seems to have worked okay. I'm not getting any errors anyway. And if I jump over to the management console, first of all, if I go to the CloudFormation service, and this is the stack here, simple app stack. Now, just to be clear, where did it get that name from? Got that name, I think, from here. Yeah. So whatever name you give there, that's what you'll see in CloudFormation. So the stack, and it seems to have created it successfully. Now, how do I see evidence that it has created the necessary resources? Well, one of the resources, if we go over to the Lambda service, although there will be other resources as well, but for now, we go into the Lambda service and select functions. Here's the Lambda function resource. Okay, so that's just sitting there. Now I want to actually trigger if I go into it, and we will look a little bit, poke around inside and what actually is stored kind of or associated with our Lambda resource. Okay, we'll look at that some other day. In terms of triggering the execution of my Lambda, what you can do with any Lambda is trigger it from the CLI. And that's what I'm going to do in this case. That's the only way actually that I can trigger it. So and in order to do that, I need to know the name of the Lambda function, which essentially is, it's kind of this is the full name. that the Lambda service has generated for my, and it's the Lambda service that generates this name. And it's obviously kind of a concatenation of the stack name, the actual function name, simple fn there comes from, I go back to my stack file. You can see there, simple fn, that's where it gets that from. And the rest then is just a hash that it has randomly generated. Yeah, so that's the full name. I can actually get that from here. I just want to get a list of all of the functions, Lambda functions in my AWS account, and in particular in the EUS1 region. Don't worry about this now. This question that it's asking me here, that's just specific to my the CLI tool that I'm using here. So you won't get that. Okay, so there's the function name. So if I just grab this and Q gets me out of that. If I go AWS Lambda invoke, again, those of you that did the cloud architecture would have probably done this last year. So to trigger the Lambda, just need to give the function name here. So when I hit return here now, the AWS CLI is essentially going to send a HTTP request to the Lambda service, asking it to execute this function. Now, I could have included a payload in the request in the form of a JSON object. I'm not doing it here, so I'm not really giving it any payload. The thing at the end here, you do have to, this is just a requirement of the CLI, you have to specify the JSON file where you want the response that's returned by the Lambda function, where you want it to be stored. It won't actually output it to the screen. So if I hit return, again, don't worry about that. That's specific to me. So it looks like it executed okay, getting a status code 200. But if I look over here on the left, there's a file called response.json. And if I open that up, what you're seeing here is essentially what was returned by my Lambda function, the return message from my Lambda function. In fact, it's the entire structure that I'm returning. Yeah, in particular, like there's this bit here, and we can see that in the, where's my JSON file gone? We can see that here. Okay, so I think that proves to me that the Lambda function did run, because I am getting the right response message back from it. The only other thing is, in the Lambda function itself, I have a console log statement. So the question is, where can I see the output from the console log that is executed within a Lambda function? And the answer to that is you go to the CloudWatch service. So let's do that. Now, and in particular, we want to go to the CloudWatch logs. Now, for every Lambda function that you have, the CloudWatch service will create a log group. And for every execution of a Lambda, it creates a log stream within that log group. So you've got one log group per Lambda function. I only have one Lambda at the moment, so if I go into log groups here, there should only be one log group, and there is only one log group. And again, if you kind of look at the name of the log group, it kind of takes it from the, obviously enough, it takes it from the function name, but it also precedes it, telling us what type of resource is this log group associated with, because CloudWatch logs are not just used by Lambda, they're used by lots of other services as well. So this particular log group is related to a Lambda function that's part of the Lambda service. And if I go into that log group, there will be a log stream down at the bottom here. There'll be a log stream for each execution of your Lambda function. Although really, it's actually for each micro VM that has been spun up to execute your Lambda function. And as I was kind of trying to explain there earlier on, the Lambda function may be executed multiple times within a micro VM if there are multiple kind of uh, multiple sequence of events that actually occur. Like if I actually ran the AWS Lambda invoke command, if I ran that quickly enough, a number of times, then we would find that we would have multiple executions within one log stream. Anyway, if I go into the log stream, this is what a log stream looks like. And just to understand, it's kind of broken down into different parts. The init part here, that relates to the initialization part of your Lambda function. Now, we didn't have any initialization code, but this is just indicating where the initialization part of the log stream is. Like if I had console logs outside of my function, those console logs would actually appear here. Okay, it doesn't arise in this case. So anyway, that's what the init refers to, the initialization. The start is the start of your actual handler function itself. And then here, this one here, which is immediately after the start, that's the first console log within your Lambda function. And you may have many. We don't in our case. We only have one. The end here is clearly kind of an indicator of the end of the execution of our Lambda function handler, or Lambda function. So init, start, then what you have between start and end depends on how many console log statements you have within your Lambda function. We only have run. And so if we expand this, we can see here, I was invoked. That is what I actually tried to console log. Console log, I was invoked. So console logs, as always, console logs are useful kind of when you're debugging. So you will find yourself probably sticking console logs into your Lambda functions when you're trying to debug what's going wrong, if something is going wrong. And then you'll be jumping over to CloudWatch logs to see what's actually being outputted by the console log statement. Okay, that's that. Any questions about that, I wonder? No. Okay. Um, the title here is Lambda integration, but what we mean by Lambda integration here is what other services can trigger the execution of a Lambda function. And it turns out that many of the, probably most of the other services, or certainly many of the other services, can trigger the execution of our Lambda function. And it's not so much limited to what's being shown on the diagram here. The overall point is that lots of other services within the AWS suite of services, be they serverless or not, they can actually trigger the execution, or they can generate the event that is linked with the execution of our Lambda function. So that's what we mean by Lambda integration. Now, there are three integration models associated with the triggering, if you like. There's the synchronous model, the asynchronous model, and the pole-based model. Let's quickly talk about each of them. The idea with this synchronous integration model is that the client, whatever the source of the event is, the client waits for the Lambda function to respond back to it. That's kind of classic synchronous communication, right? Even though the communication is over the network, the client does actually wait for a response back from the Lambda function. And that's really the kind of communication that we had when we triggered the Lambda from using the AWS CLI. So the AWS CLI, even though it's kind of the edge case, it uses synchronous communication with your Lambda function. The trigger events options. Oh yeah, so like here are some examples of other services, excluding the CLI, other services that follow this synchronous integration model. So an API gateway, which we'll look at later on. You can actually link a load balancer with a Lambda function. So when a load balancer receives a HTTP request, you can get the load balancer to route that HTTP request to an actual Lambda function. Last year in the cloud architecture module, you would have linked it to an EC2 instance, but you can actually link it to a function. The SDK, like every AWS service has an SDK associated with it. So in the case of the Lambda service SDK, what that would allow us to do is to write an application that runs outside of the AWS cloud. So I could actually have an application that's running on my laptop here. And if I was using the Lambda SDK, I could actually communicate or send requests to a Lambda function running in the cloud from my application that's running on my desktop, or an application running anywhere else outside of the cloud. Function URLs we'll see in a second, actually. Now, one of the consequences of this synchronous communication is that the client is actually responsible for handling any errors. So if the Lambda function throws an exception, then that comes back to the client, whatever the client is, and it is responsible for dealing with the exception. Or if the Lambda function times out, remember I talked about you need to set a timeout for your Lambda function. Well, if for whatever reason the Lambda function executes beyond the timeout period that you have allocated for it, then in that case, the Lambda service will return an error back to the client, and it's up to the client to deal with it. Typically, what the client might do is it might retry, might send the same request again. Doesn't know for certain why the Lambda function timed out. Like it may time out, for example, because the time it took for it to make a connection with a database. Let's suppose you wanted to talk to a database. That connection, creating that connection was quite slow because the database service was actually slow. So that might be why the Lambda function actually timed out. It wasn't so much that it was doing too much processing. Whatever the reason anyway, it kind of falls back on the client to deal with that in whatever way is kind of appropriate. Here I'm just illustrating, okay, the different kind of, so if we're using the which one is this? The CLI, which is kind of what we demonstrated. Just to make sure now, like you're not talking directly to the Lambda function. You always have to remember that the Lambda service is in here between. What you're actually talking to is the Lambda service, and the Lambda service takes care of triggering the execution of the Lambda function. And the same applies here. So API Gateway is a service that we'll use later on. But so you might have an application, or it could be just a browser or some other kind of HTTP type client that's talking to this API Gateway resource. You would have to provision this, and we will do that later on. And you send a request to the API Gateway, and it's the gateway then routes the request to your Lambda function. But again, it's not talking to the Lambda function directly. The Lambda service is here in between. It receives the request and it triggers the Lambda function. URLs, you can actually, and we'll do that at this stage now, it'll be next week, but you can actually get the Lambda service to generate a unique URL for your Lambda function. And that was actually what I wanted to do next. How am I on time? Check my watch. Let's see if we could do a quick demo of that. Okay, so this is how you do it. You're not creating a new resource now. Um, you're just essentially what you're doing here is you're asking the Lambda service to generate a unique URL for your Lambda function. And we leave out that bit actually. So we don't want any security associated with it. And CORS is that's okay. And I'm going to I am just outputting the URL. Sorry, I'm not the wrong one. This is the one I should be outputting. Okay. So I'm just making, well, okay, I'm just making a state change to my stack. The state change in this case is I'm adding some new configuration. I'm not adding any new resources. I'm adding some new configuration to my Lambda function. In particular, I'm getting, as I said, the Lambda function to generate a URL for me. So I can just do CDK deploy again. And that worked. And if I scroll back here, here's the URL. I just grab that, copy it. I can just go straight to a browser because it's going to be a HTTP GET request. Wouldn't you know? Oh yeah, it needs to be HTTP. It's not HTTPS for now anyway. That should not be the case. Because I disabled that, I thought. Let's go back here. I'm not requiring any authentication. Why is it saying that now, I wonder? And it shouldn't be HTTPS either. Sorry, now let's just shouldn't be doing that. Let's see. What am I getting wrong? No, I'm missing something because I can control whether it requires authentication or not. And that is by means of this property here. But I said I don't want any authentication. But it seems to think it seems to be still asking for authentication. Just try one other thing, which is I'll try Postman. All right, Postman. Yeah, it's consistent anyway, but I'm not sure now why it's rejecting that. Anyway, maybe it's telling me to stop actually lecturing. Okay, I'll just to look at the labs. In terms of this lab here, again, we haven't done enough to get through all of it, but you could You could get as far as this section here. There's other stuff as well. I know somebody looked at DynamoDB last year. Again, just like last week's lab, really. If you're adventurous, you could plow on a little bit further on it. But I need to cover a lot of this stuff really next week now. I didn't get as far as I wanted to be honest with you today. Okay, I am going to stop there. Again, if there are any questions, I'm happy to take them. I really don't know why that demo didn't work at the end, but there you go. These things happen. No. Okay, we leave it at that, and I'll turn up for the lab on Thursday, and you can contact me on Slack as well if you need to between now and then.